So we've been working with lasers in class. So let's look at how do lasers work. Let's answer this question here. This one's going to be a little more complex. We'll sort this out. So light from lasers is the brightest light known. Its heat can be so intense that it can burn a hole in steel. There's actually laser cutters that cut steel and metal in different manufacturing companies. So here's how lasers work. A light-producing substance, could be a gas or a liquid, is put into a sealed container. Right here, we get this material. An electrical source then excites the substance, causing the atoms of the molecules to release or emit light. As each atom sends out a light ray, it falls in step with other rays, and the beam becomes bright enough to pass through the mirrored opening as a controlled beam of laser light. So let's sort that out. Lasers are more than just powerful flashlights. The difference between ordinary light and laser light is like the difference between ripples in a bathtub and huge waves on the ocean. You probably noticed that if you move your hand back and forth in a bathtub, you can create small waves. But as you continue to move your hand back and forth, consecutive interference patterns, you can actually create a much larger wave at a particular pattern. So imagine doing this a few million times in the open ocean. Before long, you go from small waves to a mountain-sized waves towering over your head. A laser does a similar thing, only with light waves and not with water. It starts off with a weak light and keeps adding more and more energy, so the light waves become even more concentrated. So by now you should have some background of how light works and what light is. So here are the key parts to understanding lasers by comparing them to a flashlight. So we're going to compare a flashlight to that of a laser. A flashlight produces white light comprised of all the different frequencies that we call color, right? Roy G. Biv. A laser makes monochromatic light of single and very precise frequency and color, right? You can have green, blue, red. You can have all kinds of different colors here. A flashlight beam spreads out. This is called diffuse. It spreads out rapidly, right? We've looked at the inverse square law. Whereas a laser is a narrow beam that can cover a much greater distance. We can actually have our laser travel all the way down the hallway. Whereas a flashlight, we can only see it at a very short distance. However, here's a key difference, and this is a good analogy. I've got a couple pictures here. A flashlight consists of all colors jumbled together, white light. A laser, the light of a laser is all in step. The crests and the troughs are lined up perfectly with every other wave. This consistency is called coherent, or it has coherence. Think of a flashlight beam as a crowd of people waiting to get on a train, pushing and shoving down the platform. They're all in kind of their own step, acting kind of at different motions in different degrees. However, a laser is like a parade of soldiers marching in step, precisely in rhythm with one another. So what is a laser then? Well, a laser is an acronym for light amplification by stimulated emission of radiation. So it sounds pretty complex. This picture looks pretty funky, but let's make sense of it. A laser is created when electrons and atoms in special glasses, crystals, or gases absorb energy from electric current or another laser and they become excited. The excited electrons move from a lower energy orbit to a higher energy orbit around the atom's nucleus. And when they return to the normal ground state, the electrons emit a photon, which is a particle of light. So in our glow stick lab, we observed a chemical reaction that bumped the electrons into a higher energy state. And then when they fell back, we got the fluorescence, or in this case, the chemiluminescence. With a laser, electric current, right, battery powered, this is what bumps the electrons into a higher energy state. And when the excited electrons fall back to their stable or ground state, they emit a particular wavelength and frequency, thus color. So it's similar to the chemiluminescence that we did with the glow stick. It just doesn't use a chemical reaction. Instead, it's using electric current. It's actually getting electric energy that's bumping the electrons to a high energy state. And when it falls back down, boom, it kicks out a photon. That photon is light, and the frequency is its color. So in conclusion, the photons emitted in the lasers are all at the same wavelength and are coherent with one another, meaning the crests and the troughs of the waves are in lockstep. In contrast, ordinary visible light comprises multiple wavelengths and is not coherent. Laser light is different from normal light in other ways as well. We look at our flashlight here. We have all the different colors. Roy G. Biv, right? It spreads out, diffuse. First, the laser is different. It contains only one wavelength, one specific color, right? All of these wavelengths. Notice that their crests and troughs are consistent. They are coherent with one another. The particular wavelength of light is determined by the amount of energy released when the excited electron drops to a lower orbit. And second, the laser light is directional. Whereas a laser generates a very tiny beam, a flashlight produces light that is diffused, right, in all these directions that are spreading out. Because laser light is coherent, it stays focused for vast distances. It can even travel to the moon and back.